Hello everyone, in this video you're going to do something really cool. You're going to get a buffering type of a symbol, but you have turtle sim with different colors like this, and you're going to have the turtle sim keep rotating by just dropping out different colors when it's rotating in this journey. How we do it is that we use the ROS clients, and we use C++ to write these clients. And the way we do it is that we use two clients inside a node, which kind of commands one commands a service which we defined earlier in this, like the previous video, where based on true or false, it goes in a circle or it just stops. And the second one is the service which the turtle sim gives, which kind of changes the color of the line which the turtle sim draws. So these are the two clients which we would define in this node. And I would be explaining how you would go about defining this in C++. So to create any package, what we do is go to first, we go to the src, and then we use this command, ROS2 package create, and then we use the build type as cmake, and then we define the name of the package and then the dependencies which are involved. In the client package, we have the similar folders which are like launch, source, and then files like cmake and package xml. In order to understand this package, we'll dive deep into the code, the C++ code, which we have written as client node.cpp. As usual, we include the necessary header files. The header, we should be careful where to include the service types. Here we're using two major service types, which are standard services, setbull, and then turtle sim setpen. So I'll be explaining how we use this later. But one thing to take into account is that the setbull here, it's S capital and D capital, but here it is S and D small, but separated by underscore. So this thing is something important you need to take into account when you define these header files. And then you include all of these different C++ header files, which we'll use later. And let's dive deep into the class definition. So in this class called service client turtle sim, we also inherit this class called RCTP. So here is where we initialize all of these. So how we do that is that first we declare what is the name of this node, and then we declare two clients and a timer. So the way we declare a client is that we use this create client and then type of the service which the client would use, and the name of the service which it's going to send request to. This is the same for client 2 as well, which we like targeted to turtle1 set pin. This first service is what we defined in the previous video, where if we give true, the turtle bot moves in a circle. And this is one of the predefined services from TurtleSim, which helps us to change the color of the line which the TurtleSim draws during the simulation. And then we define this timer node, timer, which is used to run the whole service on and on in a loop. So this is the way we create the timer. We use create wall timer, and then what is the frequency, like we need it to run every 1 second, and then we also bind with the callback function. Here we use the callback function called timer callback. And then these are some of the variables, and this is where we seed the random numbers, which we'll be using later to color to change the colors. In the private section of the class, we define the timer. So here you can see this is the callback called by the timer, and what here we do is that we check the service status. Either the send request has been, like, the service request has been sent and then the response has been done, or we have not. So based on that, we either send the request or we reset the service, so that we can loop through this service request again and again. The next one is void send async request. This guy. This is the method which we can send a request to the service. So what here we do is first we have like a basic for troubleshooting, where we figure out if the clients have failed, either it has waited for too long or it has been interrupted. And the next Place is where we define requests. We define each of these requests, and the way we do that is we make a pointer to this type of to instance of this class called standard service set pull request. So this how this works is we define the class where this service is defined and the particular request. So we get this instance of this class, and then we assign it to request one, and then the same way we do it for request two. And once we have a pointer, which is an instance of this class representing the request, what we do is that we assign values to the individual members of this class. So how it works is that we assign request one and the data of this to be true, and then request two, which is set pin, which basically has uh, 5 requests, and it doesn't give out any response. So all the requests, what it needs is that the color RGB, any value between 0 to 255. We use a random number, which I define here, and then we define the width of this line, which the tourism draws, and then this is on off, whether to turn it off or turn it on. We keep it false. Um, Once that's all done, we just log these values so that we know what color we are sending, and after that we use result future to get feedback on whether the request has been sent. So how we send the request is that we use the name of the client, which we had defined earlier, and then we use this async send request method of this class. So async send request, and we give the request, and then we give the callback name of the method over here using standard byte. And then we also define this placeholder so that we receive the response using this placeholder. And this placeholder is defined based on the number of response, like the number of variables which are under the response. So all of these are one response or zero. So I just defined one. If it's more, you need to give more. The same way for result future 2 as well. And once all of this is done, we give the variable service call true. And so and then we give like the status 1 and status 2 to see if the response is ready or not. So this one will let us know that if the service has processed the request and is ready to deliver the response. So these are the two callback functions which we call using once the response is received. So once we get a response, what should we do? That happens in these callback functions. So here is how we define it. We define the type. We define a set pull, but here we define it as the shared future, which is how we get the response. And then we define it as future. And here we define response to be future.get. So this is how we get the values which are there in the response. And then we check the particular response, which is like a variable in this response called success, which is part of the set pull. And then we see if this is true or false. If it is true, then the service has been successfully executed. So we print this, and also we print what the message is and using the response message, or we print that the response has failed. Once that's done, we assign service 1 done true, and then we use this method, which we define later, to update whether both the services are done. This is callback 2, which is similar to how we defined before. Only difference is the type. The service type is going to be different. So here as well, here we do not get any response, but we call this function because that's how even if it doesn't give you the actual response, but this response will be called back. So we type that response set pin success, and then we give service to done true. Yeah, and initialize all these variables. So here you can see we initialize, we declare client 1, client 2, and all the other variables we use in this class. And once that's done, we declare the int main, and where we call this whole class. So we initialize RCLCPP, and then we define an instance of this class, and then we use RCLCPP spin to keep this service client running on and on until we request a shutdown. So this is how we define a class which acts like a client, and this client, basically this is how we define a node, and this node has two clients, which is constantly one is telling the service to move in a circle, and the other one is changing the color of the line drawn by the turtle sim. So once you have this done, the next thing what you would go and do is go to the CMake list and make sure you add the executable. So you have to, because we're working with C++, we need to ensure that this file is converted to an executable named client node. And then we also declare that this executable depends on the following libraries. So here you can see the same thing. Here we need to mention that this one depends on these packages. So if you go down and then you give this, which is standard, where we give like this client node has to be used, and then you also tell that in install you have launch. So this is the way how when you do CMake, the internally it knows where to look for the file in the install directory. And then the same way, package XML, make sure to include all the packages you need over here. And once that's done, you create your launch file. So the launch file is same how we created for all this, like the service or the publisher. It's the same way. We include these header files and then generate launch description, and then we write the name of the package, name of the executable, and then output as screen. So once this is done, you have the whole things necessary for your node to work as a client. Now that we have finished all the code, now let's dive in to see how the code works. So to do that, we go to the ROS on workspace, and then once we go into the respective workspace, we give call con build. Once you have the package built, then what we do is that we source this, and then we are ready to run. So first, let's get our turtle sim running. So ROS2 run turtle sim node. So now we have the turtle sim. Place it here, and next we will run the service which we had created in the previous video. So we first source it. Once we source it, then we call that ROS2 launch service package service node. Now we have the service which helps us to run, like turn the turtle so in a clockwise direction based on the command true or false. And now we'll call the client which commands this turtle to move in a clockwise direction and also change the color of the line. So ROS2, first we source it, bash, and then we launch client package client node. So you can see here how the whole thing works. So you can see that the turtle sim starts to move in this big circle, and also you can see that the colors are changing as it moves over here. And the way our code works is that first you can see that send a sync request, and once that's done, then we define the request where we give different colors for in the RGB scheme, and you can see that the response is not ready. Initially, it's processing, the service is processing the request, and once that's done, then it says timer callback executed, which means the service was fully executed. And you can see that both returned some response, and based on that response, you can see that the sprint statement is being given, whether it was success, and you can see that both the response was good, like set pin and also the service which turns the turtle sim. And then once this all is done, it then loops again. It says send async request, and then a randomized RGB is generated, and then the same thing goes on again. So this is how you can get the turtle sim to do a very cool buffering loading symbol. And that's it. So this is how you would go about and set up a node which acts as two clients and controls whatever you need based on your C++ program. And this can be used for n number of cases wherever you have to control a server programmatically. And this can be very helpful because you can have a big system where you have a lot of different services running, and you want to call each services at different point of time based on your current state. And that's when writing a client would be really helpful, and this video would help you to do that for any of your project. Thank you for watching, and subscribe to get more of robotics related content.